Now let's try to understand a spanning set in R3. So here's a related question which I'll explain you now. The question is, determine the value of x such that the point A minus 1, 3, 4, point B minus 2, 3, minus 1, and point C minus 5, 6, and x all lie in the same plane that contains origin. So this is the question before us. Let's try to visualize what we are trying to say here. So that means, let's say we have a plane. Let's say this is our plane, right? And in this plane, we have these set of points. So I'm not drawing an exact diagram, but I'm trying to show you that there is an origin here, right? So this is the origin, and this point minus 1, 3, 4. Let's go minus 1, 3, and 4. Let's say this point is here. So that is my point A. So let me draw. This becomes a position vector from O to A, right? So that becomes from O to A a position vector in this plane. And point B for us is minus 2, 3. So it's minus 2, 3 units to go y, and 1 down, right? So let's say it is somewhere here, and we say this is my point B, and so OB is the vector here in this direction, correct? So these points actually give us the vectors. Now the question is that you need to show, so the question is, determine the value of x such that the point A, B, and C all lie in the same plane that contains origin. So we need to find the value of x so that C also lies on this same plane, right? R3 has got so many planes, right, like this, but to be specific, there could be only one value of x which will lie on this particular plane, and we need to figure out what that value is, right? So I hope you understand here that two vectors actually signify a plane, right? So they can span anything which is there in this plane. That is kind of important. So if point C is on the plane, then it can be spanned by the vector OA and OB. In other words, OA and OB will form a spanning set for the vector OC, right? So that is how we are going to approach this problem. Now if OC is a spanning, can be spanned by OA and OB, then we can write like this: OC should be equals to A times OA plus B times OB, right? So that is what we need to understand when you're doing this problem. Given two points in R3, rather three, because we are given origin also, or we can say given two vectors in R3, then they can span third vector only if it lies in the same plane. Otherwise it cannot span. So that is the whole criteria here, okay? So now let's try to solve and get the value of x. That is, for what value of x will point C lie in the plane which contains OA and OB, correct? So OC is from 0 to this, which is the same value. So I'll use column matrix to solve this. Minus 5, 6, and x, that is OC. And A times OA will be minus 1, 3, and 4, plus B times OB will be minus 2, 3, minus 1, right? From here we get our equations, and that is minus 5 is equals to minus A, and here we have minus 2B. And the second equation will be 6 equals to 3A plus 3B. Now this can be simplified, right? So let's simplify it. We can write this as dividing both sides by 3. We get 2 equals to A plus B, right? So we kind of simplified it. That's good. And the third one is x equals to 4a minus b. Okay? So these are our equations, and let's number them so that we can utilize them to solve for a, b, right? And then eventually find the value of x. So the first one is, you can see, let's check while we do it. Minus 5 is equals to minus a minus 2b. So this is our first one. The second one is 6 equals to 3a plus 3b, which we simplified, and we could write this as our second equation. We divided everything by 3, getting this result. And the last one is x equals to 4a minus b, right? So that is our third equation. It's a good idea to check your equations. Now from here we can solve for a and b, right? So we know equation 1 and 2. If we add them up, what do we get? Let's do it here. So what I'm trying to do is I'm adding equation 1 and equation 2. So if I do that, I get x minus 5, 2 minus 5. We are adding 1 and 2. So we are adding these two equations, right? Yeah. So 2 minus 5, so a minus a 0, and we are adding, so we get here minus b, right? So we get minus 3 equals to minus b, or 3 is equals to b. So we get a value of b here. Now since we know b, let's call this as our equation 3. Now we can substitute b in equation 2 and find the value of a. So we are using equation 2 and 3, and we can write 2 equals to a plus 3, and so a is equals to minus 1. So we get the value of a and b. So we got a equals to minus 1 and b equals to 3. So once we know a and b, from equation 3 we can find what x is. So we get x equals to 4 times minus 1 minus 3, which is minus 4 minus 3. That gives us minus 7. So therefore the point C is equals to minus 5, 6 and minus 7. So that is how we can solve for C using these equations, right? Now what did you learn from here? Important thing which you learned here, that if you have a set in R3, right, then what will it span? So what do you have here? If you have a spanning set, in R3, spanning set of two vectors, right? Set in R3 of, let's say, two vectors, right? Then it can span in contained plane. That is important. It can only span in that particular plane, right? It cannot span any other vector. So in a way, if you have to prove that 3 points are on the same plane and they have another point, like origin was given to us, then we can use linear combination and prove that all the 3 points are in the same plane, right? So that is kind of an interesting approach to this, rather an interesting application of linear combination and spanning set. I hope you appreciate. Thank you.